Hello dear students. So in the previous class we started with refraction of light and we studied what is refraction, what is the reason of refraction, what is refractive index, that is absolute refractive index of a medium. If when light passes from one medium to the other medium, we calculate the relative refractive index of medium 2 with respect to 1. That also we've studied, and then we saw refraction of light through a rectangular glass slab where light refracts twice, and we saw some results. We also did some numericals. So let us move forward towards spherical lenses. We've studied spherical mirrors. What were spherical mirrors? We know two types of mirrors. One is plane mirror, okay, the one which we use in our homes. The other two types of mirrors are spherical mirrors. Spherical mirrors were like you take a big spherical glass, okay, which is hollow from inside. You cut it from one end. This piece which you get like this, you paint it from one side and the other side will be like polished. So it will become a reflecting surface and one side will be tinted or painted. Now here also we'll study two types of spherical lenses, like two types of spherical mirrors were concave mirror and convex mirror. Similarly, spherical lenses now. Firstly, what is a spherical lens? A spherical lens is a piece of a transparent refracting material. It is a piece of a transparent refracting material. Okay, like you all might have seen those glasses. Okay, the glasses of your grandparents must be wearing. Those are lenses. Okay, that's a transparent piece of refracting material. Okay, basically mostly it's glass only. Then magnifying glasses you all have seen. If you all have seen magnifying glass, then that also consists of a lens which magnifies the object which you want to see. Okay, so the image is a magnified one which you see. So a spherical lens is a piece of a transparent refracting material which is bounded by two surfaces. Two types of spherical lenses we will study: concave and convex. Concave lens and convex lens. Now how is the spherical lens formed? You take two big spheres. One big sphere which is a like solid sphere, solid glass sphere. Solid means inside also there's glass. Okay, and you take one more. Okay, most of the times both have the same radius. Okay, both the spheres have the same radius, but it's not necessary that they should have same radii. Okay, and when you remove this part and you remove this part, you get a concave lens. A concave lens here will be fully filled with glass. It has a partition. It is made out of two parts which are stuck together, and this part is this side of the lens, this uh, uh, like surface, this curved surface is a part of one sphere, and the other curved surface here, this one, this curved surface is a part of the other sphere. Okay, so you can see that this curved surface has radius, let us say r2, and this curved surface has a radius r1. Okay, so a convex lens has two spherical surfaces which are bulging from both the sides. It's a convex. It is thick in the center and tapered towards the ends. Okay, and this has we'll study about the terms later. For now, you just understand that it is made out of two parts. Okay, both are curved, both are bulging out. Similarly, when you have two surfaces which are thin from the center and tapered from the ends. Okay, they are thick at the ends and thin at the center. Such kind of lens is called a concave lens. It has a cave like structure for both the spherical surfaces. Okay, in a convex lens both the spherical surfaces are bulging out. In the concave lens both the spherical surfaces are like tapered inwards. Okay, mostly a lens has two spherical surfaces. You might also find some lenses which have one surface flat and one curved surface like this. Okay, these are single curved surface lenses, but mostly we come across lenses which have both the ends, both the surfaces as curved surfaces. And our study will be on these two types of lenses only. Okay, so let's look at the terms, some important terms uh, related to spherical lenses. So the first one is aperture. What is the aperture of a lens? The diameter of the curved surface. Okay, if this is the curved surface of the lens, this will be the aperture here. Okay, the diameter of the curved surface. Now a curved surface can have this diameter, it can have this diameter, whatever. Okay, so that diameter of the curved surface is the aperture. The diameter of the curved surface. Okay, now what are centers of curvature? For both the lenses, like I told you, both the parts of the spherical lenses are formed out of they are parts of two big spheres. Okay, so centers of curvature, a lens will have two centers. Like we studied the mirror was made out of one sphere only. Mirror was a part of one sphere. Okay, so there we used to define center of curvature of a mirror as the center of the sphere of which the mirror is a part. Here the lens has two curved surfaces which are part of two big spheres. So two big spheres will have two centers, right? So every lens will have two centers of curvature. Like I told you, this surface is a part of this sphere and this surface is a part of this sphere. Okay, so here we consider, if you consider this surface as surface 1 and this surface as surface 2, then this surface is a part of this sphere, so its center is C2. Okay, and here, or since this is 1, you can call it as C1, center of curvature 1, and this surface is a part of this sphere, so its radius is here, so C2 is this radius. So the centers of curvature of a lens are the centers of the two spheres of which the lens is a part. Okay. Similarly, for a concave lens, this is a concave lens. This is surface 1. This is curved surface 2. This surface is made out of this sphere, so this will be C1, and here you have this will be C2. Okay, this will be the center part of the sphere, right? So the two centers of the spheres of which the lens are a part are known as the centers of curvature. What is the principal axis? A straight line passing through both the centers of curvature. This will be the principal axis. What is the need of the principal axis? Firstly, it is the straight line passing through both the centers. Secondly, it will be like used to keep the object and get the image. Okay, on the principal axis we keep the object and we get the image, right? Okay, so that's the principal axis. What is the optical center? The geometrical center of the lens. This is the optical center. Okay, this is the optical center denoted by O. This is the optical center O. Okay, so the geometrical center of the lens is the optical center. The geometrical center of the mirror used to be the pole. Why do we need a pole? All the distances, object distance, image distance, focal length, center of curvature, radius of curvature, all these distances are measured from the pole, the geometrical center of the mirror. Similarly, the optical center is the geometrical center of the lens, and all the distances are measured from the optical center. Okay, so these are few terms, important terms related to spherical lenses. Okay, in the two more things are there. Principal focus. What is a principal focus? For the principal focus of a concave lens. What is the principal focus of a concave lens? So here a concave lens, remember, is called as a converging lens. What is it called? A converging lens. So you take a converging lens and here you get, this is C2, this is C1. Okay, the distance measured from the optical center to C2 is, this is R2, the radius of curvature. Okay, and this is R1, the radius of curvature, right? Now when light rays, parallel light rays, fall on the lens, on a concave lens, they get refracted once here, this is air and this is glass. So medium will change and refraction will take place. So instead of going like this straight, the light will bend towards the normal. Okay, rarer to denser. So the light bends towards the normal, and then while going from denser to rarer medium, again it will bend. Okay, so you get the light ray, after having two successive refractions, they pass through a point, or all the parallel rays which fall on the spherical lens, on the concave lens, they are focused or converged at a point. That is the principal focus of the concave lens. Okay, that is called the principal focus of the concave lens. So the focal length is the distance of the principal focus from the optical center, and principal focus is half of the radius of curvature here too. Similarly, for a convex lens, sorry, this is a convex lens, I'm so sorry. Convex lens is a converging lens. For a concave lens, here a concave lens is called as a diverging lens. Okay, it is called a diverging lens because parallel rays, this is the principal axis, this is C1, this is C2 for example. Parallel rays falling on the concave lens, they are diverged like this. Okay, so here these two rays will not meet after refraction. So where do we get the image? We reproduce them back like this. Okay, and the point where the rays appear to come from, or where they meet virtually, is the principal focus of the concave lens. So here also the focal length is the distance of the principal focus from the optical center. Radius of curvature is the distance of the center of curvature from the optical center, and focal length is half of radius of curvature, right? So this is principal focus and focal length of a concave lens and a convex lens. Okay, so in the next class we will study how do we get refraction and how images are formed using the two spherical lenses. So by the time, please revise spherical lenses, the important terms, and go through them and make your notes. Thank you.